the full screen, the PowerPoint?
Yes, we see the screen. Thanks, Carlos.
Okay. So, good morning and good afternoon. I want to thank Francesca and the AKD20 Subcommittee for the kind invitation to be here today. So this presentation is about road safety inspections and how we can extract relevant information regarding roadside safety from their reports. This research is part of Progress, a project that was funded by CEDAR, in which the results of a review of available EU roadside safety standards and guidelines were combined with the experiences from national road authorities in applying these guidelines and standards. So one of the primary objectives of Progress was to determine to what extent national road authorities in Europe and their contractors are capable of implementing and maintaining compliance with the standards and guidelines throughout the life cycle of roads. And under the Directive on Road Infrastructure Safety Management, RISM, the European Union member states agreed to implement a system consisting of 5 supporting procedures, that including road safety inspections. So road safety inspections are a proactive tool for detecting safety issues on existing operating roads, consisting of regular, systematic, on-site inspection covering the whole road network. So road hazards and safety issues detected within this activity are described in a written report. Many EU member countries have already adopted the road safety inspection procedure, and in Ireland, these inspections have been carried out on all national roads since 2012. So, in Ireland's case, an individual inspection report is prepared by each team for each inspected route, containing a brief description of each safety issue, an informal risk assessment of each identified hazard, and recommendations to deal with it. The large number of issues described in the inspections and the detailed description of each item yields a large-scale data set, which may support identifying patterns of common conditions and related interventions. Roadside safety can be improved by identifying run-off road crash conditions that tend to co-occur in these events, followed by evidence-based roadside safety interventions. And that is why we chose topic modeling, a machine learning approach. And in this study, topic modeling was used to identify co-occurrence patterns on attributes related to run-off road crashes, as well as the corresponding patterns of road safety interventions as described in these Irish inspection reports. This research applies latent directly allocation, LDA, a common method for fitting a topic model to analyze the topics of the inspections. These topics are divided into 2 groups. One is the problems found, and the other is the proposed solutions. A topic model allows us to identify topics within a collection of documents based on the words contained in each document. Here, a document is a sequence of n words, and a word is the basic unit of discrete data, defined to be an item from a vocabulary. Underlying the bag of words assumption, that is, the order of words in a document can be neglected, LDA portion of topics, and each topic has its own word distribution. So looking at data, each inspection report includes attributes such as the ID, the identification number, whether the issues occurred on the main line or on the roadside, a detailed description of the safety issues and also a description of the proposed solutions to eliminate the safety issues or to mitigate their consequences. For this study, 54 road safety inspections gathered over 6 years were analyzed, covering more than 4,000 kilometers of roads. So now, looking at the results, this table shows the 25 extracted latent topics for the problems record set, the first set. The topics directly related to roadside issues are shaded gray. The top 10 terms for this record set are also listed. And in this table, you can see here a similar table, but for the solutions record set. Again, topics directly related to roadside issues are shaded gray, and the top 10 terms for this record are also listed. So to provide a better understanding of the LDA's latent topics, this figure presents some examples of the topic-specific words probabilities for the 25 topics of the first set of the problems record set. For instance, the word hazard has a 13% probability of being generated from topic 1, whereas verge has a 2% probability of being generated from the same topic. Again, in this figure, we have the same idea for the topics of the solution record set. Here we can see that the word hazard has an 11% probability of being generated from topic 11, whereas pole has a 3% probability of being generated from the same topic. In short, there are 4 topics directly related to roadside problems and 3 topics related to roadside interventions. So, to conclude, our results show that important keywords relating to the forgiving roadside and clear zone concepts, as well as the relevant European technical standards, are absent from the extracted latent topics. The absence of the clear zone term in those topics may reveal a lack of application of this concept in Irish inspection reports. It is also worthwhile to point out that the frequency of topics related to roadside safety is higher in the problems record set than in the solutions record set. And meaning that problems are more easily identified and related to the roadside area than interventions may be. This also seems reasonable, as sometimes roadside safety issues may be mitigated by interventions in the roadway itself. For example, improving road surface characteristics and correcting geometric deficiencies. And I hope to finish in 8 minutes. Thank you.
Thank you.